I'm not sure if you get what I mean. Can you access the card? Yes. And the TAT is divided into a couple of steps. You're first supposed to do the TAT, finish it. When you are done with the TAT, there are questions that you won't understand. And then that's where the TAT comes in, the TAT session. You are supposed to ask the questions during the tutorial session. You're getting it? And then the 10 remaining minutes in your TAT session, you're supposed to be done around that time. You will be given a classwork. A classwork consists of only, I think, 2 to 3 questions. It's not much. You're supposed to finish those questions in that 10 minutes. You're not supposed to submit the TAT, but the classwork is supposed to submit it. You getting it? Yes. And then the classwork acts as a register that you attended the TAT. It also acts as a register that you do attend my classes. If you are not submitting those classworks, which means you were not there. If you were not there, which means you are not one of our students. If you are not one of our students, you're not supposed to write our exam. If you're not writing our exam, which means that you're not going to pass this course. And if you're not passing this course, chances are you're not going to graduate. So it also going to depend on what is your plan. If your plan is to come here and explore, which is fine, I mean, you're just here to explore. Let's just hope the funding is not they're not going to cut your funding, or you're not going to be expelled. But either way, it will depend on your plan. And then the next thing is, I had students who recently registered, so they are late, maybe by just 1 course or 2. So if you are one of those students and you missed some of the lessons, fortunately for you, I did record the lessons. So I've uploaded them on RL Connected. You can access them, the lessons. Or if you prefer the slides, you can just go through the damn slides. Come on, guys. But if you feel like you just want to feel like you were there, you can just go on YouTube and then you type Gmail education for us all. Right? Let me see if I can get here. This is what's this? You type here is supposed to be and then you have education for us all. Let me see. There is no space in between for us all, and then you hit enter. So you will see me sitting there. I'm a little bit cute. Can you see? Yeah. So when you see there, these are the lessons that I have uploaded, right? And then you can just click to the playlist so that you can access them in order. You getting it? Now these are the lessons, all of them. Now that you have these lessons, this one here, I suppose that is supposed to be the homework that I gave you. Let me see. If you did not do the homework or you don't understand it, I think these were the questions. You remember those questions? Yes. I solved them here, so the answers are here, right? And also, if you have noticed, there was also another question. I think we did not do it here in class. I tried to solve it here. What was that question? I'm just trying to see the question here. You remember this question? The one that had a denominator somewhere. Yes. This question is solved there. You're getting it? But in lecture 6. So those who missed the lessons, you can just access them there. Getting it? And when we are revising, if we couldn't finish in class, I'll just throw the video there. You getting it? Yes. That's all there is for those who are left behind. And I think our groups for tutorial, I think everyone now is sorted. If you are not sorted, then you're not supposed to be here. I'm kidding. If, let's say, you're still not allocated or you can't find your name, just send an email to Dr. Shina Oloninju. You know his email, right? The other doctor was here, my senior. He's the one who's supposed to help you with that stuff. You getting it? But if you don't know his email, you can drop me the email and forward to him. My email is, everyone should know my email by now. I think you're tired of seeing my email. Yeah, this is my email address. You can drop me an email. And then another matter is that of a class app. Guys, leaders don't hide. I don't know about you. You're supposed to show up in numbers. I want to tell you that I also have this problem. I want it to be sorted. Don't you want to be that kind of guy? Yes, you stand up for students. So if you feel like you want to be a class rep for this class, it's not like every day you're gonna come and stand here, guys. Come on. You're just gonna create a WhatsApp group for this class so that if one of you is having a problem or all of you are having a problem, you discuss it there. The class rep will take the matter to me or to the department or to Sheena, depending on where he's supposed to go to or she's supposed to go to. You getting it? That's what it's supposed to do. It's not that big. And if there is an announcement that I forgot, the class rep will remind you guys. That's all there is to it. We are trying to avoid that thing of, I get an email, I can't respond to it now because I've received 400 emails at once. So we're trying to remove that thing of answering the same email over and over again. You getting it? Yeah, before you sleep, what did we do yesterday? What is the function? It is a rule. It is a rule that assigns a function, guys. It is a rule that assigns one element in its domain to a unique element in its range. So we have, technically we have two sets. Can I write here? Okay. Let me do this. These are the consultation times for those who don't know. You said that we have a function, we're supposed to have two sets. And whenever you have an element here, it's supposed to be assigned to some element there. And this is D for domain, this is E for range, or whatever the alphabet you would like. Right. Now, I gave you a simple example. I said, okay, suppose you have 1, 2, 3, and then this side, let's say you have 1, 2, and 10. You have these two things. And now I assign this there, and then I asked you, is this a function or is it not a function? If it is a function, is it a one-to-one or many-to-one? Is this a function, guys? Yes. Why are you saying so? Yes, thank you very much. Now, those who are saying this is a function, if I place an F here, raise your hand. I want to see if there is hope in this class or not. Those who are saying this is a function, raise your hand. And there is some hope. Those who are saying it's not a function, raise your hand. Oh, there is no hope that side. Those who are just, say I'm just confused. Raise your hand. Okay. We said that a function is a rule that assigns an element in its domain. Is this element assigned? This is not a function. Because all the elements in the domain should be assigned. You getting it? But now, if we decide to restrict this domain and say that we don't have this tree here, and remove this term here, is this a function now? Yes. Now, this is a function. We got this function by restricting the domain. You getting it? So we just selected a liquid domain and say, okay, this will be a function if we say the domain is this piece. You getting it? Yes. Now, can I take another example? I just want to check that and then we can go to calculating these domains. Right. Suppose I plot now, where's this thing? Suppose I plot a curve and I say this is a y, this is an x. Here we have a 1, and then we have a line that is passing through 1 that is going from negative, positive, is going to positive infinity and also going to negative infinity. So is this a function? Yes or no? Is this a function, guys? Okay, is this a function? This is a function. Because if you place a vertical line test there, it's going to cut the curve once until the end. You're getting it? So the vertical line test passes to prove that this curve is that of a function. Now, is this one a function? Yes or no? Why not? The vertical line test fails to prove that it is a function. Is that what you're saying? What are you saying there? It is not a function. Is it a function? Why are you saying it's not a function? Oh, okay. So if you look at 1 here, 1 has so many outputs. These are the outputs that 1 have. So we don't want it to have 1 input value having so many outputs. You getting it? Yes. Or the vertical line test overlaps with that straight line there. Or the vertical line test fails to prove that it is a function because it cuts the curve infinitely many times. You getting it? Yes. Now, how do you calculate a domain and what is a domain? A domain, write it down, it's very important. This definition is very important because I want us to analyze definition by definition. What is a domain? A domain is a set of all the possible input values such that the function is defined. Getting it? Yes. That definition is very important. So when I'm asking you to find the domain, I want you to find all the values of x that are making the function defined. You getting it? Yes. That's the meaning of a domain. Now, if let's say I'm saying find the domain of this function, what is a domain of that function? Then one can tell me the domain of that function. Yes, ma'am? Okay, we have one possible answer. 2. X is okay. All you have said is correct, but there is something missing. There's a piece that is missing. Anyone want to add that piece that is missing? Yes, ma'am? X is greater than -2. So that's the piece that was missing. From 0 up to negative 2. That was that piece that is missing. From positive 2 to that negative 2. That was what was missing. Have a question? Okay. Now, what do you do to find the domain? Right. The first thing that you check, there is a square root there. When is the square root defined? Whenever whatever is inside there is bigger than or equal to 0. So x plus a 2, we want it to be bigger than or equal to 0. Do you get it? Yes. We said that we don't want anything inside the square root to be negative. That's why we're saying that. And now that you have this, how do you solve for x if you have such inequality? I said someone expose. What are we exposing? Are we exposing? Are we transposing? Or are we transporting something? So we're not exposing. I had you wrong. Okay. We are exposing these two or transposing it. I don't know the proper English. But we are taking these two to the other side, right? When it goes to the other side, it changes the sign. So you have x is greater than or equal to minus a 2. Right. This is your domain. But if you want to be a professional, okay? Greater than. What is the square root of 0? Thank you. So for this one, you can just say, okay, your domain, we usually specify with that little f if it's necessary to say that this is the domain of this function f. Right. And we say, okay, this domain is a set of all real numbers x, right? Such that, that line is such that, and then you take this thing and plug it there, and then you close. Is that hard? You can't see it. You can't see it. What is here is this thing. I had this side, that side is going to be that, right? So this is just going there. That's all there is to it, guys. It's not that hard. Or you can just say the domain of f is equal to, is 2 minus 2 included? Yes, so you can have these square brackets and then you have a minus 2 to positive infinity. Is infinity included? Because we cannot touch it. This is also your domain. Is that hard? You can use any of these two guys. You will get full marks. Do you have to know both these two methods of writing? Yes, because you don't know how your multiple choice question will look like. Just have to know those two things. Come on, guys. So this is your domain, and then that's it. Now, can you find the domain of this function? Do you think you can? Come on, guys, find the stupid domain. This domain is just stupid. It's just sitting there. It's waiting for you to find it. Come on, guys. I trust that you can do this. Why? Because in this course, you either get a distinction or you fail. There is no in between here. If you are not getting a distinction, you must know that you're going to repeat it. Because if you don't know factorization, which means you cannot solve inequalities, which means you can also not be able to plot functions, which means you can also not be able to solve for x, then can you be in between? I don't think so. You either give me an 80% plus or you don't make it. That's it. And of course, one thing that I know about the university is very generous. They will make sure this course is here next year. And I can make sure that I speak to the HOD that this course is here so that I can do it again next year. What is the domain, guys? When is this function not going to be defined? If the denominator is equal to 0. So you don't want x and x minus 1 to be equal to 0. That's what you don't want. In other words, you don't want x to be equal to 0, right? And you also don't want x to be equal to a 1. Is that what you're saying? So what you want to tell me is that the domain that you found is the set of all real numbers x such that x is not equal to 0, x is not equal to a 1. Is that what we're saying? Okay, that is the domain. Can you see this domain is stupid, guys? It's very, very, very stupid. Did I do something wrong here? Okay. Yes, ma'am. Yeah. Let's start from scratch. What we are saying, we have this nice thing here, this function, right? We want to find the set of all values that is making this function defined. You get it? Now, we said that if you have a fraction, when will a fraction be undefined? When the denominator is equal to 0. So we don't want the denominator to be equal to 0 because anything divided by 0 is undefined. We want the defined part. You getting it? Yes. So we say that we don't want this to happen. I mean, we don't want this to be equal to 0. In other words, we want this to be not equal to 0. You getting it up to this one? Yes. Now that you have this, can you solve for x? Yes. If you solve for x, for this thing to be equal to 0, either this is equal to 0 or that is equal to 0, or both of the two are equal to 0. You getting it? So when you're solving for this, x is going to be equal to 0. It's going to cause that thing to be undefined. So we don't want it to be equal to 0. And then if you look for this part here, when x minus 1, because here we have x minus 1 is equal to 0. But if this happens, we're going to have undefined there. So we don't want it to happen. And then we take this minus 1 to the other side, it's going to be positive. Are you happy so far? Yes. Then x is an element of real number, that is your domain. X is an element of real number such that x is not equal to 0 or x is not equal to 1. You getting it? If you don't know how to write this, you can even write this in words. That x is an element of real numbers. That's my domain. X is an element of real numbers such that x is not equal to 0 or not equal to 1. You getting it? Yeah, I mean, maths is using symbols, but at the end of the day, we are trying to translate words. We don't want to keep writing. If I just put an x there, the sentence is complete with an x alone, right? For those of you who might end up doing applied maths, there's a course that has logic and something. So a whole sentence can become an x there if you're doing applied mathematics. You get what I mean? Or even if you're solving a case, you become a couple. You can just say, okay, if x is not there, and x is not there, where x is the culprit, oh, you must be there. You get what I mean? So your x can be anything. Are you getting up to this part? No question. At the back. Or are you still digesting this? It's okay to talk about maths, guys. Unless you're talking about something else. I mean, you know that if, let's say, you want to pass maths, find someone who's not getting it. Explain it to that person. The person who's explaining will get it more than the one who is explaining. This thing is explained to. You get what I mean? So just find someone who's not getting it. Make sure that you're not the one who's always not getting stuff. You must be the one who's always getting stuff so that you can explain to someone who's not getting it. First of all, when you're doing that, you first get to understand what you don't understand yourself. And even if you have to set a consultation, you know that I don't understand this part. That's where this thing is. And even if you have a group, you have to make sure that in that group you are the one who, even if you don't know what the hell is going on here, lead them. Yes. What is this one? This one is for sets. The shape, Oh, is my handwriting that bad? Guys, I thought my handwriting is cute. I thought I had the best writing in the world. I don't know. That's why I didn't choose medicine. I thought I'm in the right place. Alright. Okay. I want to show you something here. This bracket is this bracket. Let me see if I can get it here. Is this bracket? Can you see it? No. That was not supposed to happen at all. Maybe it's the computer. This is supposed to be like this. Those brackets are used for listing of things. If you want to list things, if you want to list a sequence of things, of objects. Yes, it's not this, it's this. Yes, maybe my hand was too fast. But these brackets, the ones like this are open brackets for open interval. But open interval, which means you have a dance of numbers. You have numbers that you cannot list one by one when you have this. You getting it? But this last number and this last number is not included. But when you have this, you still have a dance of numbers, a continuous number of numbers inside. You cannot list them one by one. Everything that is there, you have this. But this one and that one is included. But when you can list things one by one, 1, 2, 3, 4, 5, and so forth, you use these ones. You getting it? So when we are saying x is an element of real numbers, we're just assuming that I'm listing this x. X is a set of real numbers, such that x is greater than that. You use these ones. Are you happy now? Okay. Then I have to get out of this. Now the solution for this one is simple, guys. We did it. So it's going to be x is a set of all real numbers, such that x is not equal to 0 or that. Or you can use these brackets. But in this case, you can see the brackets, open brackets, because 0 is not included, 1 is not included, infinite cannot be touched, negative infinite cannot be touched. That's how you end up using these ones. Now, another way of, forget about that. When you're doing your analytical geometry, did you do it? Yeah. I got it. Now, you ended up having a relation that is x squared plus y squared is equal to some constant. You getting it? And then we said that is a cycle. It is a relation because this is relating x and y. You getting it? Yes. Now the question is that a function? Why not? Didn't you study that thing? Did you study it? Let me start there. Did you study it? Is it not a function? Guys, why are you studying things that are not functions? But okay, it's fine. It's fine. Maybe some of you do not do that, but it's fine. Okay, now that you have that, I'm kidding, guys. Why are you saying that is not a function? Because if you place a vertical line test, it's going to cut there and cut there. So it is not a function. You getting it? But now, what is the domain of that thing? Can you tell me the domain? Anyone who can try? What is the domain of that thing? Yes, sir. Thank you for helping us. Alright, you are raising your hand there. What are you going to say? Okay. Oh, you are supporting him. Why are you supporting him? Because he's a guy. I'm kidding. Okay. Look into this. We talked about a domain. We said a domain is the set of all their input values such that, is that a function? So we cannot talk about a domain. Getting it? We cannot talk about domain at all for that case. But if we split this into two, let's say for this part, we just solve for y here. Remember that if you're solving for y, you're going to have y squared is equal to 1 minus x squared. You get that part. And then after that, you do what you do on the left and you do it on the right. So you take the square root, you take the square root there. I didn't talk about any plus or minus. I just did something on the left and I did something on the right. And then for this part here, you can see that as long as that part is defined, the square root is always positive. So you're going to get the square root of 1 minus an x squared. But this one, what is that? We talked about it. What is the square root of y squared, guys? Yes, it is the same as the absolute value of y. Then you can, let me remove this, it's not supposed to be there. And then the absolute value of y is plus or minus y is equal to that thing there. That's where the plus or minus comes in. And then once you have that, you will end up having this nice thing there, your y. Now that you have that, can you see that this part here can be plotted? And can you see that it is a function? Can you see this part that it is also a function? This is how this thing is plotted, right? Okay, is this part a function? Is this part a function? Why? Yes, which means that by either splitting the range of the function, we can, the range of the relation we can get if it is a function or not. You getting it? Yes. Now, another thing that you can do, this, if you notice that we have two functions here. Now, because we have two different functions, we can talk about the domain. And then someone said, what is the domain? What did you say is the domain of the previous relation? X is greater than or equal to? What did you say? What is the domain of this function, guys? You want what is inside the square root to be positive. In other words, you want 1 minus x squared to be greater than or equal to 0 for it to be defined. You getting it? Yes, when you have this, you know that this is a difference of two squares. You can factorize it, isn't so? And then you can deal with it. You know how to factorize, you know how to deal with inequalities. We are done with that. But this is how you find the domain. You solve that inequality there, and then you are done. Now, yes? Oh, you are there. As long as you will understand that when you are taking the square root of x squared is going to be the absolute value, which is a plus or minus x, it's fine. You have it? But remember that when solving inequalities, the first step is find critical values. After finding critical values, what do? You draw the number line. After drawing the number line, you pick the points in each region to find out the signs, the positive or negative. And then after that, you choose your desired direction, you place your arrows in the line segment, then you can conclude. I'm fine with it. You are happy? Yes. You are not forced to factorize, but you need to factorize at some point. Now that you have that nice thing here, can you see that if, let's say, you have a function, f of x is equal to the absolute value of x. You know that the absolute value of x, we defined it, right? Now that you have that, this is a graph of that. The question is that a function? Is it a function, guys? Okay. Okay. Is it a function? Raise your hand. Is it not a function? Raise your hand. Don't do this, guys. Don't like it. Just say, this is not a function. I can stand up for it. I also want to be a class rep. Okay. Now, if we place a vertical line there, how many times does it cut? If I place a vertical line there, how many times does it cut? If I place a vertical line there, how many times does it cut? If I place a vertical line there, how many times does it cut? Is it a function? If it is a function, how many times a vertical line test should cut the curve? How many times the vertical lines are cutting this curve? Is it a function? Yes, it is a function for this one. But also note that if I were to draw, any questions so far? Okay. If I were to draw this, I were to go like this without lifting my finger. I can draw it without lifting my finger, which means that is continuous. You getting it? I can just continuously draw the graph without pausing. You getting it? So that curve is continuous. And also another thing that you have to notice there, look at the domain of that function. It is splitted into two. Do you get it? Do you get that it is splitted into two? Yes. When you have a function of that kind, you have this domain of that, which means we are describing another piece. We are describing another piece. We say it is a piecewise function. Say piecewise function. Tell your neighbor, not me. This is a piecewise function. Okay. Now, if let's say you look at this one, let's start. Is that a function? Yes or no? Guys, is this a function? Okay. What is the value of? Okay. If I place a vertical line test there, is it gonna? How many times is it gonna cut? Here. 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 Okay. Let me just undo that. Is this function defined at that point? Is it shaded? Guys, is that thing shaded? On the previous slide, what happened? As a domain, then that domain is actually is fine because that function is defined everywhere. But when you are splitting it into two, we are just trying to emphasize when is this function going to be negative, when is it going to be positive. You get it? Because we're just splitting it. It doesn't mean that saying it's defined from negative to infinity, so no, it is. But we are trying to specify the properties of the function. You getting it? What I wanted to emphasize here is that that's splitting, talking about the properties. And here is the thing. If you want to write that function in terms of A, can you? If you're going to write from negative infinity to positive infinity. That's why we are splitting it. Because if we are writing it in terms of A alone, we need that. We cannot just say from it. We only need that this is going to be A if it is positive. Unless you're just going to say plus or minus and then you hide. You getting it? Yes. This one here is a whole, guys. Can you see it? Which means the function is. So if I'm placing, let's say, it's coming on top, the function is going to pass through there. It's going to get inside, and then there at this point. Okay, can you first see here that there is a hole? Now, is it defined? Is the function defined at that point? Okay. Now, how many times does a graph cut at that point? Is it a function? Yes. Also, this one you can see that it is a piecewise function. You're getting it? Now, this is one piece. This is another piece. We are defining this function into two pieces. That's the meaning of piecewise. The reason it is a function is because whenever you pick, if x is equal to 0, what is the value of y in that graph? If x is equal to 0, what is the value of x? If x is equal to 0, what is the value of y? It is, guys, it is 0. Someone is saying 1. Those who are saying 1, I want to see your hand. Guys, by just looking here, if x is equal to 0, this piece is not defined. Is it? 0 is not included there is no equality. It's only less than. Can you see that? This is the only piece that contains a 0. So 0 is only defined by that function. Are you getting it? So when x is equal to 0, y have only one output. Can you see that? That's what we mean by that. Simple. It's not that hard. Here, the original function, if you were to put a value there, you are going to get undefined. So think of this in this case of having a fraction. You have a numerator and a denominator. When you are factorizing the numerator, you get something that is in there in the denominator. They end up cancelling, and then we specify that we don't want x to be that. Think of it that way. So that whole there is saying, in that original function, whether it was a fraction or whatever, when you are plugging that value, we're getting an error undefined. Are you getting it? So it is not defined there. Are you happy? Okay. Yes. It's not going to have twice. It's not defined there. It's only defined down there. There's only one output there. If I'm placing here a vertical line in the first dot, it's going to pass through. There's not going to hit anything. There's nothing there. There's a hole there. And then it's going to hit the one function that is down there. It's only going to hit the shaded part. There is a hole there. It's going to get through without hitting anything. And then it hits the shaded part. It's because there is a hole in the other function that's up there. Yeah, there are two functions. Yeah. This is one graph. This is one graph. We have one Cartesian plane there. Yes. It's piecewise because we have two. Yes. Now that you have that, guys, note this. This is also another piecewise function. I want you to find the domain of this. That will be your homework. And I also want to add number 3. Number 3 is going to be 1 divided by the square root of x minus square root of x. I want you to find the domain of that thing there. It's nice, actually. This looks cute. So you have f of x is equal to that. Maths is cute, guys. Come on. Why are you doing maths in the first place? You know that in order for you to be good investor, you must know your domain. If, let's say, you're borrowing the government money, in other words, you're investing in retail saving bonds, you must know that government is going to accept money in this interval, which means if you are good with the domain, you're supposed to be rich. Isn't so? You don't have to be broke like me. Come on. You got it? Yes, ma'am?
Tuesday today, great one. Can you go? Oh, we have a class here.
I noticed that you put something like this instead of this, so I wanted to know if this and this mean the same thing.
Just assume that it's a set of. Okay, just. You have to attend. Yes. Tuesday, you are in the Tuesday. Great one. There's a lot. Which question? Number 5. 5.
Great I mean,
You like hotels?
is it great?
I teach in terms of
I am control.
that's the very easy. You square this side, what are you going to get? X squared. Yes. If you square that side, what are you going to get? 6 plus. Then this. Can you see that this thing inside here is the same as this whole thing? So it's gonna be x squared plus 6. No. This side is going to be 6 plus x. That will be x. Think about it. Because this whole thing here is x.
So if I square both sides, it's gonna be 6. This one
Yes,
plus x.
this square root thing, which is the same as this. So this is going to be x.
They are all 6 plus
6 plus x. Not as x.
x. Yes, exactly. So hence oh so that's big.
And then you can factorize it. Yes. Okay. If let's say you have a fraction, you don't want the denominator to be continuous. If you have a function that looks like an exponential function, whereby you have a number first and exponent, you don't want to see it to the power of 6. If you have a square root, you don't want the square root to be something that is inside the square root to be negative. Like x squared plus 3x plus 1. That one is defined differently. I can plug into anything there. Which means that. You know what rate is? If you are going this side, there's a venue here. There's also another venue still here. I think you just check the two. Who came first?
So if you left this one, I'm going to take up
What is going on here? This is can you see something here? This is 1, this is 2, and then this is 3. This one is supposed to be this day, this one is supposed to be this day, and this one is supposed to be. So it's supposed to be.
If you are not on this book, allocation 5, you will go on rows, and you can see that you attend mistakes.
You are not in this. You are not in any group.
Yes, you can find it.
Did you register there?
Yeah.
I will double check this, but I'm thinking that this is this day. This is
just like you say, my name is on the second row, but on rows it says that talk today. And
what Ross is saying, you are supposed to do. Okay. What this is supposed to mean? It means that now you know your tutor. This is only to tell you this is your tutor. This is your Right, follow what is being prompted. Follow the prompts. This is the phone. I will update. The students on. So, thank you, sir. So you are not in a group. You are not in a group. A few minutes. No, I don't want to disturb your class. Thank you. Let me do this. Yes.
Where is the